Good morning, students. Myself Pritam. Today we will discuss about an interesting topic, photoelectric effect. So this is very basic of quantum mechanics. You can say the base of the quantum mechanics from where the quantum mechanics start. So don't go through the quantum mechanics. This is a very tough word. Now let's do the classical treatment, and then we will see what will happen. So, but you have to know that you should know that the quantum mechanics first appear by Planck's blackbody radiation, and then this photoelectric effect is performed. And many scientists can't explain this photoelectric effect by assuming that the classical theory of light. We need to assume something different. That's why we need a new branch of physics, which is known as quantum mechanics. And this theory is explained by Albert Einstein, and he got Nobel Prize later on. Now let's see what is photoelectric effect, and we will explain this photoelectric effect into the four sections. So sorry, this will be plus and this is minus in four sections. So the one is experimental setup, then observation, then failure of the classical theory. Why classical theory can't explain the photoelectric effect, and the fourth one is the Einstein theory. Now let's see what is photoelectric effect. So this is a very simple phenomenon. When a metal, we know what is metal, there are lots of free electron, and it doesn't mean that the free electron can easily come out from the metal surface. It is bound somehow in the metal surface. We need some energy to emit the electrons. So when a light incident on a metal surface, the electrons will emit it, and those electrons somehow related with the incident light. That's why this electron called as photoelectron. Now let's see the experimental setup of the Einstein photoelectric effect. So this is the experimental setup. This is a very simple setup of a photoelectric effect. We can see there are two plates, cathode and anode. These are connected parallelly with a voltmeter and an ammeter to measure the current and voltage, and it is also connected with a variable voltage source. That's why we can vary the voltage in between the plates. Now what is happening in this tube? This is a vacuum chamber. There is no other ions or molecules, so it does not affect the electron velocity. You can say there is less number of scattering. Now what is happening? When a light incident on a metal surface, the electrons in the metal surface, this phenomena just happening there, will emit it, and it has some kinetic energy because the incident light will provide some energy. It will emit it from the metal surface, so it must have some kinetic energy, and it will go to this side. So after that, the circuit is completely filled, so we will get a current fluctuation, this ammeter, and this is the voltmeter. We can measure the voltage in between the plate. Now into this chamber we don't have any kind of setup to measure the velocity of individual electron or the velocity of average electrons. So if we want to measure the how much kinetic energy of that electrons can have, we have a different method by using a variable voltage source. What we are doing here? We are using a variable voltage source in opposite direction of the electron velocity. Now what we will do, if we increase the electron, if we can see that the positive terminal is here and negative is here, so the electric field is developed in this direction. And we know that electrons are negative charge particles, and the force in that electron is minus q into E. Minus is the difference of the electric field direction. So the electron will experience a retarded force along this direction. So this direction electron will have a retarded force, and along this direction electron will have the kinetic energy. Now what will happen? If we increase the variable voltage, if we increase the voltage, the less number of electron can reach to this state, so the current will decrease. After a certain value, no electron can reach to this surface. That's what we need. That is the maximum voltage. We can, this is known as stopping voltage, and this is corresponding to the maximum kinetic energy. Please note it, this is very important, that When we increase the variable voltage after a certain value, no electron can reach to this surface, because we are opposed the electron by an electric field, and we know that electrons are moving opposite to the electric field. So we will have EV naught. This is microscopic quantity V max. We can't measure it, but we can measure V naught and multiply with electric charge. We can measure EV naught. Now let's see what are the observations are there. So this topic is done. Now let's see the observation. What are the observations we observe in this effect? So the first one is instantaneous effect. So the photoelectric effect is very instantaneous effect. It takes time around a nanosecond, 10 to the power minus 9 seconds. So this thing can't explain by using classical theory of light. Why? In classical theory of light, we know that light is a wave and it has an electric field and a magnetic field perpendicular to the direction of the propagation. This is the propagation of the light. This is the direction of electric field and this is the direction of magnetic field. Electric field and magnetic field is perpendicular and also perpendicular to the direction of propagation. So this electric field can be assumed as the energy spread as a wavefront. So in that metal surface, when a light will incident, it has to be absorbed by the metal surface. For this reason, it takes time, and after it absorbs a sufficient amount of energy, the electrons will be emitted. But what is happening in this effect? This is an instantaneous effect. So when the light incident, the electrons are emitted. There is no time difference between those two events, and this thing we can't explain by using classical theory. Now let's see what is the second observation. So the second observation is that kinetic energy does not depend on intensity. What is the intensity of light? If I say that what is the intensity of light? So in classical theory, we know that the intensity is nothing but the mod square of electric field, and we know that the energy is also depend on the intensity. So we can say that the energy is also depend on the electric field, and electric field means the amplitude of the electric field. So more with the amplitude of the electric field, more have the energy of the light. So if this thing is true, then it means that if we impose the light have greater intensity, more electron with more number of more electron with having more kinetic energy should be emitted. But this is not happening here. What is happening? That the kinetic energy is independent of the intensity. So if I draw the graph, so this is the voltage V. So we already know one thing, that the kinetic energy max equals to E V naught, where V naught is the stopping potential. Okay. So this is the graph of voltage and this is current. So suppose we have a particular intensity, we are already capital I is defined as a current. So let's see, I is our intensity, small I. So the graph will like this. This I is intensity, this I is current. So for a particular intensity, when we apply the voltage, the current goes to 0. And we know that this voltage is known as the stopping potential, where there is no electron can reach to this plate, then current will be 0. This is for intensity I. Now if we double the intensity, suppose this one, the graph will be like this. This is 2I. Now what is happening? The current has increases at 2I, but the stopping potential is still constant. It means the kinetic and maximum kinetic energy is still constant if we increase the intensity. If we increase the intensity further more, like 3I, this graph will be like this. The intensity is still constant. So it means that its intensity has no involved in the kinetic energy of that individual electron. So what is happening here? The intensity means that more number of photons, so more with the number of emitted electrons. So the electrons, suppose is in I intensity there are 10 to the power 23 electrons are emitted, At 2i intensity 10 to the power 25 electrons are emitted, and 3i intensity 10 to the power 27 electrons are emitted. The number of emitted electrons are higher, but the energy, kinetic energy of the individual electron is still constant and it does not depend on the intensity. So this theory is cannot explained by the classical theory of light. Now let's see what is the third observation. The third observation is that the kinetic energy depends on the frequency. So this is the key of quantum mechanics. Now let's see the observation graph for different frequency. So at the first case, we have seen the current versus voltage for different intensity. Now let's see for a constant intensity. This is our voltage and this is my current. For a constant intensity, I am applying for different frequency. The graph will look like this. So V1, V2, V3, and intensity is constant. Suppose this is nu1, this is nu2, this is nu3. Nu is the frequency, and obviously nu3 greater than nu1, nu2 greater than nu1, and we can say that V3 greater than V2 greater than V1. These are all the stopping potential, just like the maximum kinetic energy. Now what is happening? If we increase the frequency of the light, the stopping potential increases. It means if we increase the frequency of the light, the kinetic energy of individual electron is increases. What does it mean? That in the classical theory we know that intensity is proportional to E square and energy is proportional to intensity. So this is not true. The actual case is that the energy is somehow related with that frequency. That's why we have got this kind of graph, because different frequency we have different stopping voltage. Now let's see what about the Einstein assumption in this theory. So this theory is continuous by Albert Einstein, and he assumed that the incident light is not a wave. It constitutes with a large number of photons, and these photons have a quantized energy, and the quantized energy have formed like h nu, 2h nu, and each photon have energy h nu. Now what is the first failure of classical mechanics? We know that the instantaneous effect. What is happening? That when light is fall onto the metal surface, electrons are emitted, and there is no time difference between those two events. This is not this can't be explained by the classical theory. Now the new theory is that we have light as a particles, which is known as photon. Now this photon will interact with the atomic electron. In metal there is the electrons. It will interact with those free electron, and the free electron will comes out. So it does not need any kind of absorption for this process. So it does not take any time. So that's why this instantaneous effect is completely described by Einstein. Now what is the second? The second observation is that the kinetic energy is not depends on intensity. Already we have told that kinetic energy is nothing, maximum kinetic energy is nothing but this electric electron charge into stopping potential, and from this graph we can see that if we increasing the intensity, there is no effect in the stopping potential, just increases the current only. Now from this thing we can easily say, if the energy is depends on the frequency, then how it can depend on the intensity? So this theory is also described by the Einstein photoelectric effect. First, we can see that the energy of each photon is depend on frequency, and h is already constant. H is Planck constant. The value of Planck constant is 6.626 into 10 to the power minus 34 joule second. So this is a constant and nu is the frequency. So kinetic energy should be depend on the frequency, not intensity. What is the third? The third point was that kinetic energy depends on frequency. We can see here from this graph, if we increase the frequency, the stopping potential increases. So from this Einstein relation, we can say that energy of a photon is h nu. So kinetic energy is directly depend on frequency of the frequency of the incident photon. So those three effect observation from the Einstein photoelectric effect can be described by the Einstein theory. Now let's see the Einstein photoelectric effect equation, which is very simple. Just we have to put the energy conservation law. So, and one more thing is there, that if the intensity is if the frequency is very small, it means very less frequency, there is no emission of electron. Whatever the intensity, if the intensity is large but the frequency is very low, then there is no photoelectric effect. It means there is a threshold, or you can say there is a certain value or fixed value of frequency above which photoelectric effect is possible and below which there is no photoelectric effect. And this particular frequency is known as threshold. Threshold frequency. This particular frequency is known as threshold frequency. So let's see what is the equation of photoelectric effect. So from the energy conservation, so the incident photon energy is h nu, which will be equals to the kinetic energy of the electron plus, so in for very less frequency there is no photoelectric effect. We need a particular frequency which is the threshold frequency. After that we will have a photoelectric effect. So it means that there is some kind of energy loss in this effect, and this energy is just the binding energy of the metal. This is known as Watt function, which we will describe as phi. So this is the Watt function, and this depends on the metal. For different material the Watt function can be different. So phi is the Watt function of the metal. It describes that how the electron is bound in that metal surface. So first, when a photon incident on the metal surface, some of the energy is given to the electron to just remove the electron from the metal surface, and the rest of the energy will convert it to the kinetic energy of the electron. And we know that the maximum kinetic energy of the electron is eV0, and V0 is the stopping potential, and we know stopping potential is the potential value that for that there is the current drop will be 0. And what is work function phi? We can define work function as h nu naught. So if a photon of frequency nu naught incident on the metal surface, the electron will just emit from the surface and it will have zero kinetic energy. So this is the work function. So we can describe work function as h nu naught. So by putting here we will have this equation. From that we can calculate V naught. So V naught will be h by E nu minus h by E nu naught. So see the beautiful equation of photoelectric effect. This is the stopping potential, this is the frequency of the incident photon, and this is a particular frequency, and this comes from the work function, and this depends on the metal. Okay, so if we draw the graph of frequency and voltage, we will have the slope like this. So this is my frequency and this is my voltage. It will make a slope like theta, and from that equation y equals to mx minus c, m is the slope which is tan theta, which is equals to h by e, because nu is my variable, so this will be h by e. So this is a famous experiment. This is done in our practical lab. So to determine the Planck constant and to determine the Watt function of a material. So for this we can use different values of nu. So suppose we have 3 or 4 kind of filters: red, yellow, blue, green, and for different values of nu we will calculate the values of V naught, the stopping potential, the for particular value of voltage, that particular value of voltage for which the current drop will be 0, and we will have some values of V naught and mu. Now we will plot it, and it will give us a straight line. From this equation we can see, and the slope will be h by e, and from that we can calculate the slope, and from the slope the value of Planck constant will be E into slope. And one more thing is that is the mu naught, and from mu naught we calculate the work function, which is phi equals to h mu naught. So if we extend our graph, it will cut the y-axis, the V naught axis at a particular value for which V naught will be 0, and we will get the value of work function.